host of the target is that. We've got the query string, so that looks somewhat similar to SQL injector. We specify the method that we're going to use and all of those HTTP underpinnings. But once we load it, we get a very simple shell that, if you didn't see it, there was a little bit of animation there. We thought we'd bring this.
Spent most of our time on the ASCII animation.
Yeah. Figured that was pretty cool. All right, so what it gives you is the shell. Now, while I'm functioning with Squeezer, we've also got this TCP dump happening on the other side, so you'll be able to see the queries coming through. So I'll do a very simple directory listing in the C drive. What this is doing is it's creating a series of, or it's created a table in the database with the output of that command, and it's now initiating requests for rows in that table. That request breaks up the rows into blocks, hex encodes them, and sends them back to us. So you'll see, for instance, there's a request with a header at the front, lots of hex, and .sensepost.com. Because it's .sensepost.com, that stuff will always come back to us sitting on the Sensepost DNS server. And basically there we get the output of our directory listing. Okay. To show you that other commands also work and that it's not simply hard-coded into the scripts, I will also run an ipconfig on that particular machine. And you'll notice that in the TCP dump output, what we've got is for every request, there's first an inverse lookup on the DNS server that it's sending the requests to. So this method is not quick, right? For every single block that we want, and the blocks are typically, for this method, they're about 130 bytes. For every block, we first have to initiate a reverse on the DNS server. If that thing times out, that's 2 seconds. If our request times out, that's also roughly 2 seconds. So the process is slow, but you do eventually get all of your output. What I can also do is switch away from the xbcmd shell method and drop down to that get file details method. But I will show you first. Actually, I shall do this. So what I've done now is I've switched from command execution mode into SQL extraction mode. So the shell offers you a couple of ways of inserting data into a table which you'll extract. The first is command execution, but we can also pull SQL server data out. So for instance, at this point, what I can do is there's a few pre- or hardwired queries. What I can ask for are all the tables in the database. And again, while that thing comes through, we'll see the requests will start. This particular stored proc, the get file details stored proc, is a little slower because it has to initiate 5 requests before any info, or before it eventually returns. And it's not returning. Let's just do this. Okay, so we see the requests are starting to come through. And actually they look fairly similar. We've got a bunch of hex that's coming back. You'll notice there that for every line that we're trying to retrieve, get file details has to initiate 5 attempts at looking up that particular domain. So that works. The final thing that I want to show you with the SQL extraction mode is that we can also use our own queries there. So we've got hardwired queries, but for instance, if I want to extract all the tables in the database, all the columns for a particular table, I can stick this puppy in there. And what we'll see is the structure or the format of that command is very simple. Basically, you give it a column name, a table name to draw the column from, and a where clause. So it's fairly primitive, but it is effective. On the left-hand side, you'll see that the column names from one of our tables are being pulled out through a query that we've submitted to the server. So things that you could do at this point, once you've mapped the schema of the database and you see there's a users table, you see the users table's got passwords, you can now say, give me all the passwords from that particular table, or where the username is equal to admin.
Okay, so at this point, some of you should be shouting, we thought this talk was about timing stuff. Okay, and why is Marco talking about all this DNS stuff instead?
I worked really hard on that tool. Come on.
And it's got ASCII art.
Yeah.
But what becomes interesting is SQL servers built in wait for delay statement. Okay, so for a long time, SQL injection tools have started using wait for delay. If you look at SQL Injector, PowerShell, SQL Ninja, a whole bunch of them out there. But all of them use wait for delay in a slightly primitive manner as a type of Boolean operator. So they use it for, does this table exist? If it exists, wait for delay 20. If it doesn't exist, wait for delay 0. So at best, it's giving you one piece of information. Considering the information we learned, or the stuff we learned from Squeezer, and the stuff that we learned previously from OneTime, it puts us it makes it really obvious that we can combine the two, run a command, encode it, drop it into a table. If the data is sitting there as binary, we can then decide to sleep 0, sleep 1, all of that stuff. Okay, which first takes you to another piece of proof of lameness, because the first thing that we did, and clearly some of our code is not as good as some of our other code, was to do this in Python, okay, and we ended up with something called, I think it was anothertime.py, okay, and this gave us the ability to put in a command, and again, what this is doing is what we described earlier, run your command on the server, drop the stuff into a table, then depending on the binary, sleep 1 or sleep 0 seconds. Okay, so this is exactly the concept that we were doing with DNS, except now we're sleeping. Of course, at the time that we did it, we were sleeping a fixed amount of time. So I was either sleeping 2 seconds for every one or 4 seconds for every one. And I think when we first wrote the script, we wrote it because one of our guys was on an assessment. And I seem to recall that he didn't sleep for 48 hours, actually because he was waiting for the results of this thing to come back. Okay, so that was slightly inefficient and slightly suboptimal. I'm going to leave that running. It'll come back in a few seconds. And instead, we can move on to Squeezer doing the exact same thing, but slightly cleverly.
So to carry on with what H was saying, Squeezer, if you remember, it splits the way that data gets put into the tables and the way that it gets extracted. So combining that, what we can actually do is keeping that front-end stuff of insertion the same, we can swap out that DNS portion, that DNS tunnel, and actually just insert a timing channel. And so thereby gain the same functionality that we had with the DNS, except this time we can do it through timing. What happened there? Oh, yeah. So as you can imagine, these things are not supremely quick, but what I'll do is I'll initiate a similar...
Saw the animation?
I can play it again if you want. So it's as easy as flipping your channel from time or from DNS to time. We're still in command mode for Squeezer, so I'm going to execute a hostname as well. And this one's a little different from Harun's. Gives you a status update.
So what you'll see here is we're getting back status updates, but what Squeezer does slightly differently is waits for all the results to come back before showing it to you.
And on the right-hand side, what I've basically shown you there as well is that TCP dump, just to show you that actually we don't have DNS queries in this particular channel. This is all timing-based.
Can you explain why your time takes longer?
You go for it.
No, go for it. So do your histogram.
So while this thing runs, basically the problem that probably some of you are thinking about is, okay, and there the line's coming back. The one problem that you'll find is that determining how long to wait for a 0 and for a 1 bit is a little arbitrary. So our initial attempts at that were to simply go, okay, well, we'll do it, or we'll make it 1 second difference, and if it's not effective, then we'll just up it manually. So what Squeezer does in its timing module is it introduces a little bit of a calibration effect. So to cover that, you don't actually know how reliable timing is. By its nature, you can't be 100% sure of your results. So you will always get errors in this approach. This is not foolproof. DNS you can build reliability on top of. With timing, unless you're making the same requests numerous times, you can't ever be reasonably sure. But what we can do is, with a little bit of statistics, we can try to circumvent that. Now, my statistics are dodgy at best, but they are sufficient, I think, for this. And what we basically do is we calibrate Squeezer before we start to actually use the timing channel. So the calibration works pretty simply. All we do is we send out a bunch of, or we collect samples. So we ask for, by default, 10 0 bits, 10 1 bits, and we time them. And we do some simple statistics. So we discard the outliers, basically define ranges through which we expect those bits to fall. The reason that we define ranges instead of a threshold, because typically you would say, if the time of a request is 1 second or more, we'll make it a 1 bit. If it's less than that, we make it a 0 bit. What happens if it's 70 seconds? If it's 70 seconds, you can't make any such statement, right? Because you don't know if that's complete failure on the line, there's routing problems, and so on. So we need to define ranges. The way that we've gone about it is, I think, fairly simple, and it works relatively well. We basically define these two landing pads, as I like to call them, one for 0 bit and one for a 1 bit. Okay, so to move through this somewhat quickly, basically we can draw histograms here. On the histogram, we've got 0 bits and 1 bits. We define the landing pads, and anything in between or outside of that gets discarded. The last thing about Squeezer that I'll just mention, it also supports the SQL injector.pl's HTTP error message channel as well. So Squeezer's got 3 channels, DNS timing and HTTP error messages. So it's pretty much a drop-in replacement for that, and it gives you more functionality.
Cool. So Squeezer should be available on our research portal as soon as we get out of here and get reasonable internet access. You should be able to download it. You should be able to fiddle with it. Marco just killed his mic. Okay. So what we're going to go on to next is to start to look at timing with the web for slightly different things. Okay, so when you're doing application testing, one of the things that comes across pretty strongly is that information leakage is a pretty big problem. Okay, one of the reasons analysts like it is because it's almost something you can throw into your report by default, something that says you should be using generic error messages. Okay, but typically it actually is a useful recommendation. So up there you'll find one of the popular news aggregator sites, and you'll notice it differentiates and tells us